I'm going to give you a minute or two to think about everything you know could figure out about this. It could be obvious things, it could be things that you find out. Anything that you know about this. So I'll give you a couple of things we know about this inequality. It would have a solid line. What else do we know about this inequality? It would be shaded below, yes?
Do you watch all of these?
Antonio said, you're a C. Thank you.
I saw this one dude like try to do a 50 nose grind on a Hanzo, and like he hit it on his neck, and his bone was like sticking out of his arm.
Focus. You know these two things, if you grabbed it, it would have a solid line, it would be shaded below. Anything else, it could be obvious. It has a negative slope. What else? Jacob, go back to your seat. What are some other obvious things we see? They're going to be like so super obvious. It is not a positive line. Okay. Anything else? Do we know what the slope is?
-1/3.
Okay. What else? Here.
Y-intercept is 4.
Okay, y-intercept is 4. Anything else? I can name some other things. This, you all know, is an inequality, right? That part. You know the y-intercept is positive. You know that this is in y equals mx plus b format. Those are obvious. It has an inequality in the equation. Obvious things. Not so obvious if you graphed it and found a specific solution. You could name solutions. You could name all of them. Pick any points and say, this is a solution, this is a solution, all of those things. We're not going to do that. We do have time. We're not going to do that. All right. Anything else that anyone else wants to put up here before we talk about our unit? Okay. Look at your course calendar. For those of you who actively look at this, I need you to fix something because I miscalculated dates. Tuesday the 8th should be Tuesday the 9th. It is still Tuesday, but it's the 9th. And then that would be Thursday the 11th. So it is still Tuesday and Thursday, but it's the 9th and the 11th at the end for the test and the fun day. The quarter ends the 26th. So all of this stuff will start going on quarter 3. As I mentioned last class, all of those grades are done unless you're going to retake or are missing tests. So all of this stuff is going to go on quarter 3. Starting with the Delta math that is due tomorrow on what we're going to talk about today. Then there'll be another one due on Wednesday, so next Wednesday, on what we talk about Monday. And then we're going to start the third lesson, but that one won't be due until we come back from break. That Delta math. And then quiz and tests are when we come back. So those of you on the board that have not finished Unit 4 tests, have until the 11th to take and finish that test, which seems like a lot of time, but we have today after school. I won't be available Wednesday next week, so Tuesday after school, and we have break, and then we come back, and then those days after school / after our lessons in class. You don't have that much time to finish that test, do retake stuff. I don't know dates exactly yet as to when I'm stopping quarter 2 makeup work and retake stuff. When we come back, I should know that. Questions on any of that stuff? Okay. So we are going to start a new lesson unit today. Keep working on it next week. If you are not here next week on either day, it is your responsibility to look on Canvas, watch the video, take notes on your own paper, and then you can come back and get those papers. Okay, so everyone should have these notes in front of them. Talk about some vocab before we really get into this. A direct variation is a specific relationship in which there is a constant ratio between all ordered pairs. Direct variation equations are written in the form y equals kx. So when we write this format, it's going to look very similar to our slope-intercept form, but also a little different because we're using k, not n. When we talk about k, it's going to be called different things. Constant of variation, constant of proportionality, all those things, they mean the same thing. When we're trying to find our k value, so let's say we're solving this equation for k, how would I get rid of x here? Divide it. So k equals y over x. That's your ratio. That's how we find our k. Divide y by x every time. Okay, so we're going to use that knowledge on some of these examples, starting with number 1. You're given a bunch of ordered pairs. If you divide y by x for each one and you get the same number for each one, that is your constant k, and it is direct. If any of the numbers give you a different constant, then that is not direct. You don't have a constant k. So let's see. If you need to label these, x, y, x, y. So you know which one is which. And to find k, we're dividing y over x. So for each one, go ahead and do that. 4 divided by 1 would give us 4. 8 divided by 2, 4. 12 divided by 3, 4. And I'm almost positive this one's going to be 4. Is it? Yes. So since they are all 4, I can say my constant, I do have a constant, is 4. And then I can write this as an equation. Using my y equals kx, it would be y equals my k value for x. Questions so far? Let's try one of these tables. Let's do the same thing. Here we have x and then y, so this will be negative 8 over negative 12. Divide that either in your head or in your calculator. What would you get? 2 over 3. Negative 4 over negative 6. 2 over 3 again. We're going to come back to this 0 over 0. And then 2 over 3 is just 2 over 3. So right now it looks like all of these are not the same. So we would say there's no constant. It's not direct. However, if we're thinking about this on a graph, if I start at 0, 0 and go up 2 to the right 3, I should end up at this point. If I do the opposite way, I should end up here. So even though when I divide it, it's not 2 over 3, on a graph, I can visualize that I'm still doing the same thing. Also, If this is like your slope-intercept form, what would your b, your y-intercept be? 0. Which would mean anytime you see 0 over 0, this is still direct. So our constant is 2/3. How would we write that equation? In the format y equals kx. So don't be confused that the 0 over 0 wouldn't give you the same number. Because it is 0, it is still direct. It will still go through the order. That is another piece of it being direct. It has to have a constant k and go through the order. Do you have any questions about this so far? This next part is being able to identify, are these direct variations or not, based on, does this look like our y equals kx? Is this direct? Yes. Because it looks like y equals kx, so because it is direct, what is our k value? 3. What about 6? Is that direct? Yes. What is the k value? Correct. What about 7? No. Why not? There's no x. Right. Number 8 we have to solve. Divide both sides by 2. Is this direct?
Yeah.
Yes. What is the k value? 5 over 2. What about 9? I heard a yes and a no. Why do we think? It doesn't look right. Okay.
You can just move the x.
Move the x right.
Right.
Like this. The k value would be 1, but there's something that's different between the ones that we said yes to. What's different? Not that it's first, it's by itself, because the y values, the y-intercepts for these are what? It has a d. So these are all 0. It now has a different y-intercept. It's no longer direct. So if it has a y-intercept other than 0, it cannot be direct. For 10, would that be direct? Yes. What would the k value be? -1. 11, we have to solve. If I solved this and divided both sides and left it like this, x over 2, is that direct? Can I rewrite this? Yes. How? Antonio, go ahead.
You put a 1.
So I can say this is 1 over 2x. Now is it direct?
Yeah.
So it's direct either way. You just have to know that this is also direct. You don't have to change it before you know that. Right. Most of your equations that look like this will not be, because it's going to have some b values, some y-intercept, but let's solve it just to make sure. Subtract 4x from both sides. And then divide everything by 2. Y equals -2x plus 3. Is this direct? Because of that same reason, it has that y-intercept that is not 0. Before we solve 13, do we think that is or is not going to be direct? Is it going to be direct or is it not?
It's not.
So we subtract 5x from both sides. You can put the plus 0 or leave it off. Would this be direct? Yes. Because the y-intercept is 0. Do we have any questions on how to determine if it's direct based on the equation? Once you have finished that, go on to the next page item.
Will there be any time where there will be a different variable that has y, k, and x?
Possibly. So that's a great question. You might see instead of y, k, and x, so the k should be the same, but the other two might change. You might see different variables depending on the problem. But then you would have to know what would be like your y, what would be like your x, and then just solve it that way. Great. Now we're going to do the same thing, but determine if these are direct based on the graphs. So it has to have a k value, a constant like our slope that continues all the way through, has to go through the origin. If it doesn't have one of those two things, it's not direct. So 14, would that be direct?
Yes.
Yes. What would the k value be? 3 over 2. Just really count your slope. What about 15? Why not? The y value, the y-intercept is not 0. 16?
Yeah.
Yes. What is your k value? -1/4, yes. 17?
Yeah.
Yes. And then what's your k value? What number did you say? 1. If you put 3 over 3, simplify that to be 1. Questions on how we determine if it's direct from the graph? Alright, so that is part of it, being able to determine if something is direct or not. The other part of that is being able to use it to solve. So we're going to do at least one of these, and then we'll see how much time we have left. Alright, so I'm going to rewrite our two equations back up here. Y equals kx, and k equals y over x. We're going to be using both of these in this. So when you see something like this where you're missing values, look for the ones where you have both y and x. So like in this first one, label them if you need to. We can use that to find k. So divide y by x to get negative, not -1/2, but just -2. So find your k first, that's always going to be your step 1. Then we're going to use this equation, y equals kx, with this second point. But instead of putting in all the numbers, whatever you don't have is going to stay the same, so y equals. We now have our k, and we now have an x. And you're going to use that to find x. Sorry, to find y. What would your y value be? 12, yes. So y is 12. If we wanted to double check this, I could, since I now have my x and my y, do the same thing I did here. So take y divided by x and see, do I get the same thing? Would I get the same thing? So since that works, I know I got the right answer. If you did not get the same answer, something in your math is wrong. Do you have any questions on how we just found them? Let's start one more. Found x, let's do 19. Okay. Same process. Find k by dividing x and y. So 16 divided by 4 would give us 4. Start to set up your equation in y equals kx. We have a y this time, 24, equals, our k value is 4, but we don't know x. How would we solve for x? Divide those by 4.
No.
Same as before, if I wanted to double check this, I could divide my y and my x. 24 divided by 6. Would that give me the same k value? Yes. Now, the check part is completely optional. You do not have to do that part, but it is a good way to check yourself. Do you have any questions so far about this process? When we get back from lunch, we're going to do a couple of these, and then any you guys want to see, and then move on to. So these examples are just like these. They just have more words. So we're going to do the same thing. So let's try 22. So we're going to use what's given when y equals negative 18, when x equals 3. Use those two to find k. So it would be y over x, negative 18 over 3.
-6.
And then set up your equation. We're looking for x, we have y. So in our y equals kx, 30 equals negative 6x. How would we solve for x?
Divide by 6.
So the x is negative 5. I'm not going to do the check on here, but I'll talk it out loud. If I did 30 over negative 5, I would get negative 6. It would work. Questions on that one? Okay, let's find another one. Find x. Let's do 24. So we can do the opposite. So again, find your k by doing what? Focus. How would we find our k here?
10 divided by -4.
10 divided by negative 4. Simplify that. What would you get?
5 over 2.
Negative 5 over 2. And then to start setting this up in our y equals kx, what would that look like when we set it up?
Y equals -5 over 2.
Times 12. Multiply those two. Tell me what y is. So if you're doing it in the calculator, you can use alpha y equals to put in your fraction. So again, if I took negative 30 over 12, I should get negative 5 over 2. Before we move on to the next page, are there any that we skipped over on this page that we want to see you go over, have questions about? Not funny.
Yes, not happening. It's all good, Dave. I should have been in the country. Yeah.
Ran over.
Yeah. You know, with my arms open.
Alright, for 23, let's find k by doing what? 80 over 32. Put that in your calculator. Alpha y equals 80 over 32. Simplify that.
I'm so confused.
Yeah, let's do as the decimal. Over 2.5. Okay. So which would be 5 over 2 also. So 5 over 2 or 2.5. Those wrong. Okay. And then how would we set this up?
100 equals 5 over 2.
100 equals 2.5x. Divide both sides by 2.5. What is x?
45.
Okay,
calculator.
I don't think that's right.
Oh,
Oh, they're right.
40.
Wrong.
You're not taking your calculator.
I'll give it that.
He said-
I'll never answer him right
Other questions before we move on? Okay. This next part, you're going to see that it's word problems, but don't freak out yet. One, let's talk about this part. You guys don't have this part, but you do have this. When we think about direct variation problems,
He's good. He was with me.
yeah, I know.
Thanks so much.
When we talk about direct variation problems, you have to think about as one variable increases, the other increases. So the more you study, the better your grade is. But these can also decrease together. The less you study, the worse your grade is. In general, I'm talking about you guys specifically.
Obviously.
So these either go up or down together. So we're going to read through this. I'm going to help you set it up. And then what's nice about these is what we just did is the same thing here. There's just more words. Okay. So let's read through this first. You can read with me either up here or on your paper. The sales at a baseball game vary directly with the number of people attending. If the sales for a game are $12,000, when 800 people attend, determine how many people attend if the sales for a game are $15,000. What do you find important here?
12,850.
Okay, 12,100. 800 people, 15,000. What are we looking for?
How many people attend?
How many people attend? And then also there's something else important. These words vary directly. So somewhere in your problem it's going to say the words vary directly, varies directly, directly proportional. All of those mean the same thing. It's talking about direct variation. That's how you know you're using direct variation. When you do this, whatever comes before the words, those words are going to be your y, no matter what. Whatever comes after is going to be your x. So then, every time you see sales or amount of sales, that's going to be a y. Every time you see number of people, that's going to be an x. So in our question, are we looking for y or for x? X. That's the biggest thing here, knowing what you're solving for. Then it's just like what we were just doing. Take the numbers that you have together, y and x, find k. Put that in your calculators. 15. 15. And then we're trying to find how many people attend if the sales are 15,000. How would we set this part up using our y equals kx?
15,000 equals 15 x.
15,000 equals 15x. Solve for x by dividing both sides. Guys, I need you to focus. So x equals 1,000, and since this is talking about real world, real life, 1,000 what? People.
Yeah, right.
So this will be an example. The more people that attend, the bigger the sales. The less people that attend, the less the sales. That didn't make sense, but sure. Less. Questions on that? Okay, let's do another. Read this next one with me. Or number 2. Ounces of medication vary directly with the weight of a patient. If a 100 120-pound adult requires 3/4 of an ounce of medication. How many ounces are required for a 200-pound adult? What's important here?
120
Okay, 120 pounds. What else?
Pounds, and then how many ounces are required?
100 pounds. How many ounces are required? Missing something. 3/4. Right, and the words vary directly. Okay. So then what comes before that is going to be your Y. So ounces is Y. Weight is X. Guys, focus. So 120 pounds would be X. 200 pounds would be X. 3/4 ounces would be Y. What are we looking for, X or Y? Okay. How would we find our K value?
It's 120 pounds, 200, right? Or not?
We have to use our Y and X. The two values that we know. So what X and Y value do we know?
3/4.
3/4 and
120.
120. So instead of putting 3/4, so we have a fraction, we're just going to put 0.75 over 120.
Well, you said it,
You're going to get a decimal. Sometimes that happens. What would that decimal be? Double check that. Cameron, what did you get?
1.25.
For the final answer, what would this be?
0.006.
Was
Luis, I can see that.
write all the decimals. So 0, was this right? Okay. Write all the decimals for this one, unless it's repeating, then you can leave it as a fraction or round.
Honestly,
So this is your K. Wilbur focus, Louise focus. And then, how would we set up our equation?
Y equals 0.0062 times 200.
Multiply that. And tell me what you get. 1.25 what? Ounces? Ounces. As you are doing these problems, think about, would this make sense? Let's say you switch these and you got 90 instead of this decimal. That would be 90 ounces of medication per pound. That's a lot of medication. That would not make sense. This amount of medication per pound would make sense. Or 1.25 ounces of medication would make sense for a 200-pound person. You got something ridiculous like 10 ounces of medication for a 200-pound person. That's a lot of medication. So think about, would this make sense as an answer as you start to answer these? Questions on either of these two? We're going to do one more of these, and then any you guys want to see, then you'll have time to practice. Let's skip down to number 5. And let's read this together. The income of a computer analyst varies directly as the number of hours worked. If the analyst earns $256 for working 8 hours, find the constant of variation. What's important?
Income of computer varies.
Okay, varies directly, I heard.
250, 8 hours.
256, 8 hours. What are we looking for?
Constant variation.
Okay. Constant variation, that means we're looking for K. How would we find that? That's not entirely. Yes. This would be Y, this would be X, so this is Y, this is X. So 256 over 8, which is
32.
So you can think about that as $32 per hour.
That's good.
Did it ask us to do anything else?
That's
No. So don't do more than what it asks, guys. Focus. Don't do more than what it's asking. Do exactly what it's asking. Right? Are there any others on this page or any other page that we want to see, do, go over, have questions about? Jacob. 6. Okay. And you can look through the other pages, see if you have any other questions as well. This one we'll get to in a second. Okay, so for this one, the gallons of water used to take a shower vary directly with the number of minutes in the shower. So the gallon was 48, the number of minutes was 8. We're looking for constant. So that would be 48 over 8, which is, that would be 6 gallons per minute. I should probably write that down. Any others we want to see if you go over, have questions about? So then, for the rest of class, you can be working on one of these things. Delta math that's due tomorrow on this. I would do it while it's fresh in your mind. Get it done. Not on phones. You can use your computer or an iPad. Not your phone. You can keep working in this practice packet. If you need to finish a test or want to work on retake work, you can come to me to do that. Yes.